Hi folks, today I bring you a front panel from a Philips FW320C mini sound system. Let us bring it back to life by connecting it to the plus 5 volts DC for the logic power, the less 26 volts DC for the grids and segments, plus 5 volts DC for the filaments, and in this particular mess, the plus 12 volts DC for the LED circuit. We encounter one additional difficulty involving the CD shuttle's open message appearing on the VFD and causing it to constantly exit of the standby mode. This is something we will address and resolve later on the video. Since the VFD driver is integrated into 8-bit microcontroller reference 87CP71F with 48 kilobytes of the ROM and 1.5 kilobytes of the RAM, we won't have access to modify the code residing there and thereby control segments directly. We can still use the clock function since the 32.768 kHz extal is present on the board, which indicates the real clock function on the panel. Thirdly, the service manual and the user manual are available online, which is a valuable time saver. I like to point out that the code implemented in these panels microprocessor allows you to adjust the clock without using the infrared remote. As is typical of these panels, it has a demo mode that displays an animation of the HIFI functions. We won't cover the functions themselves. We will just use a few as examples, such as on-off, a demo, clock set, volume, test mode. You can find them all in the user manual. I'd like to highlight the presence of the two CD4094 ICs, which are responsible for the interfacing with the LEDs on the panel and the adjacent button bar. Since they depend on the options activated in the panel's functions, you can easily use their outputs to control anything you want. Returning to the issue related to the open message that prevents you from remaining in the standby mode, to overcome these difficulties, we need to add two 10K resistors connected to the plus 5 volts DC to perform a pull-up on the pins 5 and 7 of the 1404 connector, respectively data and the clock, so we can observe the status of the communication attempt with the CD shutter. We also need a 3-case R to the pin 9 so that the microprocessor interprets the CD shutter as a normal status, as it is constantly requesting information about the CD player. With these implementations, the panel can be used as a real-time clock as well as customize the panel's functions as desired. After a power failure event, we stay with the 4 scores present in the VFD display. This is the positions of the digit of the hours, and to set the clock, we need to go to the clock button and press fast. We stay in front of the hour blinking. To adjust the hour, we can use the button to rewind, fast forward to advance the hours, previous button to the minutes adjust and the next to the increase the minutes. After the hour we need present in display, we touch again in the clock button. And our hour is set in display and you're ready to use, and you can see the blinking of the middle point. To run the test mode is necessary keep down the button of the program and the next at the same time, and after connect the power. You will be prompted from the version and the software present in the processor, and after you have the option to run the tests. For example, if you want to run the test of the display, you can press the play button and the VFD whole bright. Second time the play and the part of the display is on, and have information about these steps in the test mode documentation. To out of the test, I go to the power button and stay out of the test. After the power failure, the system return in demo mode, and we'll do the animation of the panel. The LEDs will bright. To stop with this kind of the animation is necessary you keep the stop button down more of the 5 seconds and go out.